Alright, so what do you do now that you have a Binary Explorer board? Well, you can check out our website off the coloradomicrodevices.com website or from binaryexplorer.com. It'll also go there. So here is the product website that you see, and there's a few useful links. One of them is the user forum, and you can get it from the top forum link here or directly from that page. And if you have some questions or other comments, you can post them here, as well as a way to share links to projects. The second thing you might be interested in is the course material. Again, that's still at the New AE website, and it's been streamlined a little bit, and there's still all the links to the various digital logic courses. But what you really want to do probably is get started with the Binary Explorer. And there's a link to the Quickstart guide, which is in a wiki format, and it's hosted on Assembla here. So you can follow this through, and I'm going to take you through it as well to really show you what to do. So one of the first things you'll need is the software. You may already have the ISE Webpack, Xilinx ISE Webpack, and you can get it from xilinx.com, and there's a download link there. It might ask you to sign in for some reason here, but you can just hit download, and here is the file. So version 13.2 is the one I often use. You can also use 10.1. 10.1 is older. It's a lot smaller, which is nice. So the download is around just the Webpack version, 2.24 gigabytes, sorry. And the install size will be around 4 gigs. If you use 13.2, it's going to take around 12 gigs to install, so it's quite large. If you can download the larger one, it doesn't hurt to have more recent. You can even get some of the like 14.4 versions, but they get pretty big. So I recommend either this 13.2 or 10.1. Either way, you'll have to register to get a license for it. It's free. When it asks you for information like your company name and industry, you can probably just put in education and just put your name again as your company name, if it requires it. So once you get that and install it, I'm sort of going to assume you're at this point. If you have the DVD in the starter kit, it comes with 10.1. Again, that's mostly chosen because 10.1 is almost guaranteed to work on most people's computers because of the reduced size and the reduced hard drive space. You also may find it runs a little faster actually than the later version 13.2. If you plan on doing more work with this sort of digital logic, you might want to just get the later version anyway, because it will work better with some of the more advanced boards you can buy. But it's very similar, so either way, you're not going to get stuck with one or the other. Anyway, so the first project we're going to do is drive the 7-segment display, and we're just going to have the switches drive that. So assuming you already have the Webpack, the next thing you need to do is download the base reference file. So the base reference file are versions of the projects configured for either ISE 13.2 or ISE 10.1. When you open ISE, it'll open in what they call the Project Navigator, so that's what it'll be called on your Start menu, Project Navigator. And this is 10.1, and this is what 13.2 looks like. So they look a little different, but basically the same idea. You can just open a project. So what you need to do now is download the appropriate one. I'm going to show you on 10.1 right now. So there we go. We download the zip. What's critical, don't just try to open the file. It's going to fail if you open it without unzipping it. So you can just, let me make a little space here. What you can do is you can just drag this folder to your desktop. Oops, went off the screen. There we go. Open that, and then if you double click on this .ise, it actually should open in the Project Navigator. I'm just going to open it manually here. So go to my desktop, and here's the folder. So I just opened that .ise file. Right, so this is then what the window should look like. So I'm just going to expand it a little here. Oops. Expand it a little here. And one thing you have to check is see these 3 symbols here. These should be by ioconnections.schematic. ioconnections is the main schematic file. So before you do anything else, right click on it and hit set as top module. If you use ISE 13.2, this doesn't seem to be a problem. In 10.1, it doesn't seem to save this properly into the project file. I don't know why. But it's critical that you set this as top module before you do anything else. Now you can double click on ioconnections.schematic, and this will open the schematic view. So in here, you can actually draw your schematic. So you can follow along with the Quickstart, and in the Quickstart what we do is we use if this doesn't show up, by the way, you may have to tab along to the symbols page here, and then you click on the top symbol, and I'm going to put a binary 2/7 segment. So the binary 2/7 segment will take these 4 bits and convert it into a number that you can read. So, binary 1, 2, etc. So all we do is we just wire up the ABCD, and let me zoom in so you can see this a little better. So ABCD just goes to each of the segments. So you can read a little bit more about the 7-segment display if you want to. These comms are ground, so what we need to do is we need to insert a ground. So under General, Ground, put it down there. Oops, and drag and drop there. You have to be careful if you don't wire them properly, there'll still be these red boxes. So in this case, for example, I haven't moved it quite properly, and we just need to drag and drop like this. Next thing I do is I drag from the input switches here, D0, D1, D2, and D3. And these go to all the switches. So this should actually be enough. So hit save. And now we need to implement it. To do this, you have to have the processes window open. And oops, there we go. And you can't be on ioconnections.schematic, so you go to the source file. If needed, select the ioconnections.sch, just click it once, and then go over to the processes window. If this doesn't appear, you can select it with the view window so you can turn it on or off. Down in implement design, we double click on generate programming file, and what will happen is it should go through each of these and you'll get a green check mark beside each one. If you get this little warning sign here, you can actually completely ignore that. Because there's some floating connections, it's giving you warnings. We don't really care. So there we go. We got the green check mark. It means everything's good. Now open up that folder again, the same folder that had this in it. What you want to check is that we have a file called ioconnections.jed, J-E-D. And if you want to find it, you can search by date modified. And this is just confirming that it generated the proper output file. To program it, we just connect our board up and you just run program.bat. And it'll pop up a window. Oops. And you always want to sort of read what it's doing. It should take a few seconds, at least 30 seconds or so. If this completes immediately, it probably has not worked, in fact. So there can be some variety of reasons for that. You can post in the forums if you're having trouble, but if it happens right away, it almost definitely didn't work. It might be you have Windows 64 and need to do something else beforehand. It might be the drivers didn't install. You can try reconnecting the board, or it might be that ioconnections.jed file didn't exist. So when it finishes, you should see this scan device output matched expected TDO values, and you just hit enter to close that window or any button. Alright, so now we have the programmed board. So you can play with the switches and see, for example, that if you put 1, it outputs 1, 1, 2, binary 1, 0 is 2, etc. So by changing the switches, you can get the different numbers. So that's a fun first example. I'm now going to show you what you can do next is you can just continue to modify this. So here I'm going to take you through then another example using this same thing. So once again, you open that ioconnections.sch. It's worth noting if you're using ISE 10.1, you might notice some of these file names and the symbols you're going to use are will have Z underscore on them. You can ignore that. It's a bit of an artifact of sometimes 10.1 seems to not work as reliably. So anyway, we previously had a single segment display here, so now I'm going to control 2 segments. So I'm going to drop down this binary to 7 segment 2-digit. If you had the single one, you can just delete it and actually put this in its place. Once again, you connect up A, B, C, D, E, F, G. So we're going to go ahead and do that. A, B, C, D, E, F, G. When you get to common 0 and common 1, it's important that you connect these to the 2 common lines. So we're going to skip the dot for now. The next thing we need is the counter. So there's this BCD counter. You can drop one down. You'll notice that the names line up. So if you overlap them and drop it, it will connect all 8 lines right away, rather than having to go through and connect them all. So the clock of the counter will connect to the 1 Hertz clock, which is this top one. And the 25 kilohertz clock, we're going to connect to the BCD driver, the 7-segment driver here. And this is going to multiplex between the 2 segments. So that's explained a little more in another lab. This is just more a quick example. And that reset line, you could either connect it to 0, or I'm going to connect it to a switch, or you could connect it to the reset switch. So let's zoom out, and that's what it looks like. So again, save. You go over to the sources, make sure IO connections is selected, and in your processes window, go to processes here, implement design, and again, generate programming file. Once again, I opened that folder that had all these files here. You wait for it to complete, and at the end of it, you can double check. You do get a file called ioconnections.ged. This .ged file is critical for it to work properly. So let's just look. That's done. And there we can see the file. So then that's the right time. It just was created. So we connect the board and we run program.bat. And once again, we expect the activity light to come on. Here we see some sort of error. It has exited right away. So this is an indicator that there's some problem. And we see this cable connection failed error. If this happens, what we're going to do is just unplug the board and plug it back in again. Give it a second and then run that same program.bat file. And hopefully that solved it. Oops. So in this case, it doesn't seem to solve it. Try this a third time. So if that happens, you can also try switching what USB port it's connected to. It could just be an issue with one port of your computer. Sometimes if a board is giving you an error, too many errors, it will actually disable that port. So it can help to connect it to a different USB port. So I'm going to try one. There we go. So I connected to a different port, and this time it worked. So it can take a bit of playing around occasionally, but for the most part it works quite well. Alright, so that's programming, and we'll give it a second here. As I say, this step should take a little while, and the activity light should be on this whole time. You'll notice the other LEDs kind of give it a bit of a odd, they may go a little bit off color or not. Once it's loaded, we should see the counter start counting up. If you move the reset switch, it goes to 0, 0. And if I go the other way, it slowly starts counting. So hopefully this has given you a bit of an idea to how you can get started. If you want to test other things, I mean, you have these other LEDs and switches, so you can start playing a bit with just AND gates or NAND gates, flip-flops. It's all in here in the design. So thanks for watching, and hope you enjoy your Binary Explorer board.